What if I told you that something ancient, something not from our solar system, just passed silently through space, and when astronomers finally saw it clearly, they froze. No explosion, no warning, just images. Images that showed a structure no one was expecting. This is Comet 3 I/Atlas. At first, it looked like just another icy traveler from deep space, but when high-resolution telescopes zoomed in, scientists noticed something disturbing. It wasn't smooth, it wasn't symmetrical, and it definitely didn't behave like a normal comet. Some say it's just an unusual natural object. Others believe it may be something far more complex, possibly older than our sun itself. Tonight, we're breaking down what Comet 3 I/Atlas really is, what cameras actually captured, why its structure doesn't match known comets, and the theories scientists don't like to talk about. Stay with me, because the deeper we go, the stranger it gets. Comet 3 I/Atlas was detected by the Atlas Survey System, a global network of telescopes designed to scan the sky for near-Earth objects. But this one was different from the moment it appeared. Unlike typical comets that originate from the Kuiper Belt or Oort cloud, 3 I/Atlas showed signs of coming from interstellar space. That means it wasn't born here. It didn't form around our sun. It came from another star system, possibly billions of years ago. Only a handful of interstellar visitors have ever been detected. Oumuamua in 2017, Borisov in 2019, and now 3 I/Atlas, each one stranger than the last. But 3 I/Atlas stood out for one reason: its structure. When astronomers first captured images of 3 I/Atlas, they expected something familiar: a solid nucleus, a smooth coma, a simple dust tail. But that's not what they saw. Instead, the comet appeared to have an irregular, fragmented shape, uneven brightness zones, and a structure that looked layered. Some images showed what appeared to be multiple lobes, almost like separate pieces moving together. This immediately raised questions. Was the comet breaking apart, or was it never a single object to begin with? Even more strange, the brightness of the comet changed in ways that couldn't be explained by solar heating alone. Normally, as a comet approaches the sun, ice sublimates evenly, but with 3 I/Atlas, activity spiked, then dropped, then spiked again, almost like something was controlling the release. Here's where things start getting uncomfortable. Most comets are often described as dirty snowballs. They're loose collections of ice, dust, and rock. But models of 3 I/Atlas suggest something else. Its density appeared higher than expected. Its rotational behavior didn't match its shape, and its outgassing was directional. In simple terms, instead of material escaping randomly, it seemed to vent from specific regions. This led some scientists to propose subsurface cavities, complex internal layering, or a structure shaped by extreme forces before entering our system. But others quietly asked a more controversial question: what if this object isn't just a comet? To be clear, there is no official claim that Comet 3 I/Atlas is artificial, but science thrives on questions. Some fringe hypotheses suggest the structure resembles a contact binary, or a naturally formed object shaped by tidal forces near another star, or something that experienced controlled fragmentation. One controversial idea compares it to Oumuamua, which also showed non-gravitational acceleration without a visible tail. In both cases, traditional comet models struggled. Could these objects represent a new class of interstellar bodies we don't yet understand? Or are we trying to force old explanations onto something genuinely new? If 3 I/Atlas truly comes from another star system, then it is a time capsule. It carries information about alien solar systems, planet formation beyond our sun, and conditions from billions of years ago. Its strange structure may be the result of ancient collisions, stellar radiation, or environments completely unlike ours. Every image captured is data. Every anomaly is a clue. And the more we study objects like this, the more we realize how little we truly know. Comet 3 I/Atlas didn't come here to scare us. It didn't come with answers. It came with questions. questions that challenge our models, questions that push science forward, questions that remind us the universe is not obligated to make sense to us. To understand why Comet 3 I/Atlas is so unsettling, we need to compare it with the other known interstellar visitors. In 2017, astronomers detected Oumuamua. At first, it was classified as an asteroid, then a comet, then something else entirely. Oumuamua showed no visible tail, no classic coma, yet it accelerated as if pushed by an unknown force. Scientists proposed exotic explanations: hydrogen ice, nitrogen ice, extremely porous material. None of them fully satisfied the data. Then came Comet Borisov in 2019. Borisov behaved more like a traditional comet, but its chemistry was different. It had unusual carbon ratios, unexpected levels of carbon monoxide, a composition unlike comets born in our solar system, and now 3 I/Atlas. Unlike Oumuamua's smooth, elongated shape or Borisov's relatively standard structure, 3 I/Atlas appears fragmented, layered, and uneven, almost like an object that has lived through multiple violent histories. 3 visitors, 3 completely different behaviors. One conclusion becomes unavoidable: interstellar objects are not rare. We simply weren't capable of seeing them before. So, how does something like 3 I/Atlas even form? Let's break it down simply. In young star systems, chaos rules. Planets collide, moons are torn apart, asteroids are flung outward at incredible speeds. Now imagine an object forming near a massive star. It experiences extreme radiation, intense gravitational tides, violent collisions. Over millions of years, layers build up, fractures form, and materials compress in strange ways. If such an object passes close to a gas giant, it can be stretched and reshaped. If it survives a supernova shockwave nearby, its structure could become compacted and distorted. 3 I/Atlas may be the result of multiple cosmic traumas, not broken, but reshaped. Its irregular structure might not be a flaw, it might be a record. Here's something most people don't realize. For most of human history, objects like 3 I/Atlas pass through our solar system completely unnoticed. Why? Because space is enormous, and these objects are small, dark, and fast. Only recently have we developed wide-field automated sky surveys, AI-assisted detection algorithms, continuous night-by-night monitoring telescopes like Atlas, Pan-STARRS, and upcoming systems like the Vera Rubin Observatory are changing everything. Soon scientists expect to detect dozens of interstellar objects every year, possibly hundreds. And that's where things get really interesting, because once detection becomes routine, classification becomes harder. How many of these objects will look normal? And how many will challenge our understanding again? 3 I/Atlas might not be an exception. It might be the beginning. Comet 3 I/Atlas doesn't threaten Earth. It isn't on a collision course. And it isn't something to fear, but it is something to respect. It reminds us that our solar system is not isolated, that material from other stars can and does reach us. Every interstellar object is a messenger, not with words, but with physics, structure, motion, composition. 3 I/Atlas tells a story we're only beginning to decode. And the most important lesson may be this: the universe is far more diverse than our categories, far more creative than our models, and far more mysterious than we are comfortable admitting. The camera didn't lie. The data didn't lie. It simply showed us something we weren't ready for. If you want more deep dives into cosmic mysteries, ancient objects, and the unexplained corners of the universe, subscribe, because the next visitor might be even stranger.